This is solving two variable systems of equations, substitution method specifically though. Separate video for elimination. This is substitution only. Your first step with substitution. You are choosing one of your four variables, meaning you have an x in the first equation and a y in the first equation, and you have an x and a y in the second equation. So four separate variables, you're choosing one of those that you're going to solve for. Meaning you are going to isolate that variable, get it by itself in one of the equations. You do have the complete freedom to pick whichever variable you want. Obviously there are some that are easier than others. For example, I probably wouldn't recommend trying to solve for x in the second equation, because at some point you're going to have to divide by 6 to get it by itself. That's going to cause you to have fractions. You can do it if you want, but most tests and such that you have in a math class or an ACT test or something like that are timed to some extent. There's really not a reason to be wasting time dealing with fractions when you could be solving in such a fashion that you don't have to use fractions at all. It'll work either way, it's just maybe not the best way to use your time. Besides that 6x, you could really make a case for any of the other three variables, I think. Personally, I would prefer to solve for this y here in the second equation, because it's only going to be a -1 that I have to deal with as opposed to a -2 or a +2 with the other variables. But it's really not saving me that much work stepwise. I'm going to have the same amount of steps to solve it out. I just feel like it seems a little bit easier, but it's definitely up to you. I'm going to go ahead and solve for y in the second equation. To repeat myself one more time, that is my choice. It does not have to be yours. You can pick any of the four variables. If you want to test yourself after this video is over, take this equation, take this system we're starting with, pick a different variable than the one I did, and try and solve it out to see if you can get the same answer, because it shouldn't affect what you get at the end. If you can get the same answer but by a different pathway, then you probably understand substitution method. Wouldn't be a bad way to test yourself. But I'm going to solve for y in the second equation. So I'll rewrite the equation over here. 6x minus y equals -2. To get y by itself, I need to first subtract 6x, giving me a -y equals -6x minus 2. And then I need to get rid of that negative. Kind of up to you how you want to look at it. You could say you're multiplying by -1, you could say you're dividing by -1. Either way, in the end, you're pretty much just flipping the sign of every single term in this equation. Meaning y becomes positive, -6x becomes positive, and -2 becomes positive. So we were able to isolate the y there. We were able to get the y by itself. That was the goal for our first part of this problem. Now we have to do the actual substitution part for the reason why it's called substitution method. What we have just established here is that apparently y is equal to the quantity of 6x plus 2, at least in the second equation. But if we're calling this a system and we're trying to solve the system, whatever y equals in one equation, y should also equal that in the second equation. So if we know that this y right here is equal to 6x plus 2, this y right here must also be equal to 6x plus 2. So why don't we take that 6x plus 2 and substitute it, hence the name, for y. Apparently that's what y equals. That's what we found over here on the right side. That's what we found right here. I mean, we didn't do that wrong. Y truly does equal 6x plus 2. So, instead of writing y, let's just write 6x plus 2. That would give me 2x minus 2y. Sorry, instead of y, let's put in 6x plus 2 equal to -14. Well, the usefulness of that is now y is gone, right? This quantity of 6x plus 2 is representing y. So instead of y, we've got 6x plus 2, which means I only have x's in the equation. Since I only have x's, I should be able to solve this out. In this case, that would require us to distribute the -2. So I'm going to rewrite the 2x, and then I'm going to distribute this -2. -2 times 6x would be -12x. -2 times +2 would be -4. And that's equal to -14. Understand, we're pretty much done with substitution method at this point. We really did all the things that are special for substitution method. Everything else we're doing is just solving out for x like you've been doing probably even before whatever math class you're in right now. If this is Algebra 1, this might be the first time that you've been solving for variables, but it's definitely stuff that you've done before if you're looking at solving systems. 2x minus 12x. Those are like terms, so I can combine them. 2x minus 12x would give me a -10x. And then minus 4 equals -14. To get that -10x by itself, I need to add 4 to the other side. Well, -14 plus 4 would be -10. Then I need to divide by -10 to get x by itself, and that tells me that x apparently equals +1. Now that I know that, remember that's only half of my answer, but now that I know that, all I gotta do is take this x value of 1 and plug it into either of my two original equations. Why don't we use 6x minus y equals -2. Right, that was one of my two original equations. So we're going to take 1 and plug that in for x, meaning now I have 6 times 1, bad handwriting, 6 times 1 minus y is equal to -2. Well, 6 times 1 is 6, minus y equals -2. I would need to subtract 6 to the other side to give me -y equals -8. And then again, either divide by -1, multiply by -1, however you want to look at it. If -y equals -8, then y equals +8, giving me a final answer of 1, 8 for a solution point. Again, just to recap, you are picking one of your 4 variables to solve out for. You're going to isolate it. Once you've isolated it, take whatever that variable is equal to, and you can use that to substitute into whichever equation you did not use. Meaning, we chose to take the second equation and solve it out, so that's why we plugged into the first equation. If you solve for a variable in the first equation, you need to plug it into the second equation. You always plug into whichever equation you didn't start out using. That is substitution method.